Hello, I am Robert Miller from Integrated Solutions for Systems. This presentation is on IS4S's ongoing development of a radio frequency selectable high-power RF system that provides the combination of narrowband electronic warfare and broadband electronic attack capabilities in a single compact flight pod-sized device. Here's a short overview of IS4S's mission and capabilities. Our motto is Speed with Discipline. IS4S is comprised of several agile core engineering teams that work independently on programs in their areas of specialization and collaboratively on larger projects for both the DoD and prime contractors. Our areas of specialty include position, navigation, and timing, energetics testing and development, pulse power system testing and development, vehicle electronics, robotics and autonomy, additive manufacturing, and decontamination systems. The Electromagnetics Division of IS4S is developing a frequency-selectable high-power RF system for aircraft-based electronic warfare and electronic attack. The performance goals for this project are shown on this slide. This technology development effort is funded by the Naval Air Warfare Center Weapons Division through a Phase 2 SBIR. This project is currently not attached to a specific aircraft platform. The primary focus of this project is the development of the core technologies comprising the compact counter-electronic weapon. There are three core technologies used: the pulse driver, which is a vector inversion generator, the gyromagnetic nonlinear transmission line, or NLTL, and the antenna, which is specially designed for pulsed applications. The primary technological advantage of this system is that it can create a tunable frequency output. The goal is to achieve tunable frequency high power output from 30 MHz to 5 GHz. The transmitted power from the system is higher than the normal radiated power range used for electronic warfare systems, but is lower power than is transmitted by the much larger land-based high power microwave systems. The power level the system produces is sufficient for damaging electronic systems via electronic attack. This system is being designed with the capability of switching between narrowband transmission for jamming functionality and broadband transmission for electronic attack. A brief description of the three core technologies of the compact counter-electronics weapon in development is summarized on this slide. First is the vector inversion generator, which is the pulse generator used to drive the NLTL. This technology is a long-term development effort for IS4S, and the Electromagnetics Division has decades of experience developing this technology. The second component, the NLTL, is used to create a high-frequency RF output from the input pulse supplied by the vector inversion generator. The output frequency from the NLTL is variable and controlled by altering the driving pulse voltage. The NLTL efficiency is dependent upon the profile of the driving pulse from the vector inversion generator, and therefore one of the key development tasks for the current project is to optimize the vector inversion generator driving pulse profile to optimize the NLTL efficiency. NLTLs have the added advantage of being compact with respect to their power handling capabilities. The antenna design for the system must be highly directional with a narrow beam width and high gain. The antenna must also be compact to meet the size requirements for fitting into a single flight pod. To date, IS4S has had great success using a specially designed helical antenna for a significant portion of the tunable frequency band required for this system. IS4S has built and tested a first iteration system and is using lessons learned from this prototype in our second iteration system design. Achieved metrics for this first iteration system are shown on this slide. 3 separate NLTLs were used to cover the frequency range shown. Power output from the first prototype meets and for some frequencies exceeds project goals. Using the lessons learned from the first prototype, IS4S is building a second iteration prototype in 2023 to 2024. Improvements on the second iteration prototypes will be made to all 3 of the core technologies in development for this program. The goals of the second prototype are to increase the tunable frequency band for the system from 500 MHz to greater than 3 GHz, and to improve the NLTL efficiencies to at least 20 to 25%. In addition, 2 more antennas will be made to cover the wide frequency band goal with higher gain and with more focused beam width. The additional antennas to be built are a smaller helical antenna to cover the 2 GHz to 3 GHz frequency range, and a log conic antenna to cover the 500 MHz to 1 GHz frequency range. Improvements will also be made to the existing 1 to 2 GHz helical antenna. Naval air warfare is seeking a compact system that can provide the flexibility of both electronics warfare capabilities for jamming and electronic attack capabilities for attacking electronics in a single weapon system for air platforms. Meeting this goal requires a compact system with a higher power output than that of traditional electronic attack systems. The prototype IS-4S is developing can fill this need for the Navy. The weapon system being developed will have a broad range of frequency tunability and the ability to change transmission between narrowband for jamming and broadband for enhanced electronic attack capabilities. IS-4S is sensitive to ensuring the approach taken is in line with the SWaP-C goals. The core technologies used for this system are cost-effective. The 2 iterations of the prototype system developed cost less than $400K per total prototype iteration. IS-4S believes the logical next step for development of the compact counter-electronics weapon system after the current Phase 2 contract would be a Phase 2.5 project starting in later 2024 or early 2025 to develop the system from a TR Level 4 to a TR Level 6. For this to be funded, it would be advantageous for the system to be associated with a specific air platform on which it would deploy. IS-4S is also developing the core technologies used for this project in other ongoing projects, and there is synergy between these parallel programs. Parallel development is helping IS-4S to explore more than one possible path to achieving the technical goals for this program, which will ensure that we have selected the best possible technology development course to reach the Navy's goals. IS-4S is primarily an engineering technology development and integration-oriented company. When the prototype system is ready to transition from the laboratory environment to the field, we would seek a primary contractor to partner with for this transition. IS-4S would stay involved in the steps necessary to make this transition. The primary contractor partner would be licensed for the production of the weapon system, and we would continue to stay involved for further system development as needed. The core technologies being developed for this project are applicable to several other DoD electronic warfare and electronic attack needs, such as compact high-power microwave systems for vehicle and vessel stopping, and counter-UAV systems. IS-4S is also applying vector inversion generators to other applications, such as flash X-ray systems, trigger generators for high-energy marks banks, and flash lamp drivers used in high-speed photography. All of these projects have value for defense applications, as well as some potential commercial civilian applications. Thank you for the opportunity to present IS-4S's compact counter-electronics weapon system development. If you are interested in learning more or talking with us about the future of this project and the core technologies involved, please contact any of the IS-4S representatives listed here.